Y'all go ahead and do the factoring and math knowledge question for today. Pause the video, and then once everyone is finished, unpause the video, and we'll go over the correct answers. So for this factoring, you're going to do a remove, replace, reduce. You're going to have x to the fourth minus x squared minus 42. We're going to replace our 3 when we go to factor it. And the numbers that you're going to use are -6 and a +7. The first step will reduce by 3. So you have x squared minus 2. The second factor will not reduce, so you're going to leave it as 3x squared plus 7. And so neither one of those will factor further with integers, so we'll leave the answer just like that. Okay, now looking at the math knowledge question. So we've got 25 buildings. Of those, 10 have fewer than 6 rooms. And it wants to know how many have 6, 7, or 8. So those 10 we can throw out. So that leaves us with 15 rooms that we're looking at. It says 10 have more than 7 rooms and 4 have more than 8 rooms. Well, we are looking for the ones that have 6, 7, or 8. So if it has more than 7 rooms, that means that it could have an 8th room. So we don't want to throw those 10 out. But more than 4 rooms, 4 have more than 8 rooms, so we do want to throw those 4 out. So if we throw out those 4, we're left with 11 that could have 6, 7, or 8 rooms. So that's going to be your answer for the math knowledge question. So we are looking at lesson 91 today. We're looking at product and difference indeterminate forms. You remember that indeterminate is 0 over 0, infinity over infinity, negative infinity over infinity, infinity over negative infinity, or negative infinity over negative infinity. Any of those would be indeterminate. And so a couple weeks ago we looked at how we deal with indeterminate forms. Now we're going to be looking at product and difference dealing with indeterminate forms. So we looked at L'Hopital's rule. If we have a function f over g and it is indeterminate when we plug in our a, and if the derivatives do exist, then we just take the derivatives and try and take the limit from there. So hopefully you remember doing that a couple weeks ago. So we want to evaluate this. And at first glance, you're like, I don't have a fraction. How am I going to be using L'Hopital's rule here? Well, you're going to write it as a fraction. So we're going to make it the limit as x approaches 0 of x over sine of x, because cosecant of x can be written as 1 over sine of x. And then if we plug in 0, we get 0 over sine of 0, which is 0. 0 over 0 is indeterminate, so we want to take the derivative. The derivative of our x is going to be 1, and the derivative of sine is going to be cosine of x. So now we're going to try and plug in our 0 again. We're going to get 1 over the cosine of 0, which the cosine of 0 is 1, so 1 over 1 just goes to 1. So this limit, when you evaluate it, the answer is just a 1. Looking at the next example, we have the limit as x goes to infinity here. Not sure if you can tell that that's what that says, but it says x goes to infinity of e to the negative x ln of x. So the first thing that we want to do is to write it as a fraction. We're going to write it as ln of x over e to the positive x. And if I plug in infinity, ln of infinity is infinity, and e to the infinity is infinity, which is an indeterminate form. So what we need to do is take the derivative. So the derivative of ln of x is 1 over x, and the derivative of e to the x is e to the x. And so now I can write that as 1 over x e to the x. If I plug in infinity, I'm going to end up with infinity times e to the infinity, which in that denominator is just basically infinity, and 1 over infinity approaches 0. And so the limit of that function is going to be 0. Okay, let's look at another example. We want to evaluate this one. Well, in order to evaluate this, we need to make it into one fraction. Right now we have 2. So the way that you're going to do that, you're going to say the limit as x approaches 0. Common denominator is going to be x times sine x. And then we're going to have sine of x minus x. And if we plug in 0, sine of 0 is 0, minus 0, that's 0. And then 0 times sine of 0 is 0. So 0 over 0 is indeterminate. So we need to take the derivative of each of our functions. The derivative of our numerator is going to be cosine of x minus 1. And the derivative of the denominator is going to be, well, we'll have to use the product rule. So derivative of x is 1 times sine x. And then derivative of sine of x is cosine. So we're going to have plus x times cosine of x. And so now let's plug in our 0. Cosine of 0 is 1, minus 1 is 0. Sine of 0 is 0, and then plus a 0. Well, that is, again, indeterminate. What do we do if we get indeterminate? That's right, we take the derivative of our functions again. So we're going to have the limit as x approaches 0. The derivative of cosine of x minus 1 is negative sine of x. The derivative of sine goes to cosine. And now we have to use the product rule yet again. So derivative of cosine is derivative of 1 of x is 1 times the derivative of cosine, which is negative sine x. And then we have plus, the derivative of x is 1, and so we have plus cosine of x. And then the derivative of cosine is a negative sine. And so that would be the product rule of x times cosine of x. So now we're going to plug in a 0, and I get negative and 0, so just 0. And then in my denominator, I'm going to write it out. Cosine of 0 is 1, cosine of 0 is 1, and then 0 times sine of 0 is 0. So I have 0 over 2, which is not indeterminate, it is 0. And so that would be our answer there. Okay, so now we're going to look at another example. We want to evaluate the limit as x approaches 0. And this says from the right, there's a little positive there. So first thing that we're going to have to do is make this into one fraction. Now, some of you may try and say that the denominator is x times the square root of x, which is not completely accurate. I'm going to rationalize this second term for you, and hopefully you'll see how I could possibly write it instead. Instead of 1 over the square root of x, that's the square root of x over x. And so our common denominator is really just an x, and then we'd have 1 minus the square root of x. So that's what you would want to write for your fraction. And so if we plug in a 0, it's not going to be very pretty because we're looking at it from the right. If you plug in a 0, the numerator is going to go to 1, because this is going to be 1 minus 0, and then we're going to have over 0. So 1 over 0 isn't going to be very helpful, but let's look at the graph. If you graph this on your calculator, it's going to do something like this. And so what is it approaching? It just is going to keep going this way, and it's going to approach a positive infinity. And so that's going to be what this is going to be evaluated as. All right, so we're going to look at one more example. The limit as x approaches 0. And on this one, we're going to start by writing it as negative 1 over x minus 1 over sine. And then we're going to have, for our denominator, x sine of x. And then in our numerator, we're going to have negative sine x minus x. All right, so if you plug in your 0 for your x's, you get 0 over 0. So we're going to take the derivative, and we're going to have negative cosine of x minus 1. And then we've got to use the product rule. So the derivative of x is 1 times sine x. And then x times the derivative of sine is cosine. And so if we plug in 0, we're going to have negative 1 minus 1. And then 0 plus 0, which is negative 2 over 0, which is does not exist. And that would be the limit for this function. It's not indeterminate because it's not 0 over 0. We got negative 2 over 0. You can't divide by 0, so the limit for this function does not actually exist. So that's how you can use the product and difference indeterminate forms. Hopefully that makes sense. On your homework, you do get to omit number 15, 16, and 19. So make sure to do that tonight so that we can go over any questions you have tomorrow.